Are the words velocity and speed synonymous? Yes, they are in our day-to-day language. However, in science, they are not. Speed is a scalar, whereas velocity is a vector. Speed has only magnitude, whereas velocity has magnitude as well as direction. Speed depends on the magnitude of the path length described by a body and the time taken to describe this path. Velocity, on the other hand, depends on the displacement of a body and the time taken for this displacement. Let's start with average velocity. A body moving in a straight line is said to be in a rectilinear motion. Let's plot an xt graph of this motion. A body starts at the origin and travels through a certain distance x meters in time t seconds. Let us mark 2 points A and B on the graph obtained. Let us study the motion of the body from point A to point B in detail. x1 and x2 are the positions of the body at time t1 and t2 respectively. The displacement delta x is the difference between x2 and x1. The time interval delta t is the difference between t2 and t1. The average velocity is the ratio of the change in position or displacement delta x and the time interval delta t in which the displacement occurs. The SI unit for velocity is meter per second. The velocity of vehicles is generally expressed in kilometers per hour. Let us take the readings from the graph and calculate the average velocity of the body from point A to point B. Delta x is equal to x2 minus x1 is equal to 42 minus 10 is equal to 32 meters. Delta t is equal to t2 minus t1 is equal to 7 minus 3 is equal to 4 seconds. V bar is equal to 32 by 4, which is equal to 8 meters per second. V bar represents the slope of the line joining points A and B. Slope is equal to tan theta is equal to x2 minus x1 by t2 minus t1. If you observe the graph carefully, you will find that the displacement is different in different intervals of time. That is, from the 3rd to the 4th second, from the 4th to the 5th second, and so on. For calculating the average velocity, we take the total displacement and total time elapsed. In other words, it is the average of different velocities obtained at different instants of time. For example, when a car is traveling on a straight road, the velocities at various instances of time, say t1, t2 and t3, are taken as v1, v2 and v3 respectively. Then the average velocity is the average of the 3 velocities recorded. Let us consider a scenario where a person is traveling from his home to his workplace and back home in his car. The path traversed by him is a straight line. When he goes to work, the displacement of the car is equal in equal intervals of time. Here, the displacement is considered to be in the positive direction. The xt graph, when plotted for this motion, is a straight line passing through the origin and making a positive acute angle theta with the time axis. The car is in a state of rest or at the same position for some time as long as the man is at his workplace. For that time span, we get a straight line parallel to the time axis when plotted on the graph. When the man returns home, the car makes equal displacements in equal intervals of time, in the negative direction. The graph now is a straight line, making a negative slope with the time axis. When the total displacement of the car is considered, it is 0. We know that speed depends on the magnitude of the path length described by a body and the time taken to describe this path. Average speed is the ratio of the total path length and the total time taken for the motion. The unit for average speed is the same as that for average velocity. That is, meters per second or kilometers per hour. When a body moves in a straight line in the same direction throughout its motion, the magnitude of the displacement is equal to the total path length. In such a case, the magnitude of the average velocity is equal to the average speed.